You're you're streaming.
Excellent. All right. Hello, everyone. Can you hear me now with the mic? Oh, I can. So I'm assuming you can hear me. The solution to file sharing isn't for us to stop doing it, but to stop governments and corporations from knowing that. My name is Ija, and today I'm going to talk to you about file sharing without consequences. First of all, I want to start by thanking the volunteers and the staff of HackMiami, Alex, Rod, and everybody else who's made this event possible. I just want to thank you for inviting me on here.
Yeah, just sit here and just when he's done, just hit the stop and stop.
So who am I? How many of you saw my DEF CON 22 talk last summer? Anyone at DEF CON 22? You happen to see it? No? Okay, maybe-ish. Okay. Well, my name is Ija, and I'm the founder of DemonSaw. DemonSaw is a new type of file sharing application that's secure, anonymous, free, and the goal is to eventually be everywhere. Today, I've launched DemonSaw 1.5. It's on Windows, Linux, and Raspberry Pi. Yes, Raspberry Pi. I did it. To be honest, it was working late Sunday night. So it's been working for a whole 6 days. So the disclaimer on the Raspberry Pi build is it's available now, command line and GUI. It's still beta. So if you find bugs, please let me know. Linux and the Windows one are fairly simple. But I'm the founder of DemonSaw. I'm the only person who works on DemonSaw. It's a part-time hobby. I have a real job that pays the bills. And then every day I get up at 6 a.m. and for 3.5 hours all I do is DemonSaw, Monday through Friday. And then on the weekends all I do is DemonSaw. So I do everything. I do the code, I do the website, I do the t-shirts. In fact, I'll be giving away a bunch of these in just about 2 minutes. So you came early, you hopefully will benefit from the answers to trivia questions. My goal with DemonSaw is to avoid a lot of the pitfalls that we see other file sharing applications fall into. Like most recently, Core Equines, with its ability to take up your CPU cycles and perform Bitcoin mining on behalf without letting you know. DemonSaw, my promise to you is DemonSaw will always be free. It will be ad-free. I will not bundle it with anything ever. I will not require you to do any sort of installation. I will not log anything. I will not make callbacks to any sort of server. I don't know what you're doing with it, and I don't care. That's the honest truth. Now, DemonSaw is a big app. How do I make money? I don't. I don't care to make money. That's why we have real jobs that pay the bills. As long as the bills get paid through the real job, then there's no need for all hobbies. So my pledge to you is DemonSaw will always be free. You won't ever be pissed off with DemonSaw. And if you want a new feature, email me. You know why DemonSaw is on Raspberry Pi? Because one of my followers from Portugal requested it in a tweet. That's why DemonSaw is on Raspberry Pi. I can't pronounce his name. It's J-A-O-A, I believe. But very nice guy. Just said he really wants it on Pi. He has a Raspberry Pi. He wants to run a DemonSaw router on it. He asked me about it. I said, why not? I'll write the code. And now DemonSaw is on Raspberry Pi. So if you want a feature, or you have an enhancement, or you want anything done on DemonSaw, you send me an email, ija@demonsaw.com, and if I can, I will make it happen as soon as possible. You could say that my life is characterized by rare moments of spontaneity and irrational decisions. Over the last 15 years, I've been involved in software development, InfoSec, and a lot of different areas of overall software architecture. Currently, I'm a senior game programmer at what I believe is the best game studio in the world. I won't tell you what it is, but I guarantee of the 6 or 7 games that I've shipped, everyone in this room has played at least 2 of them. It's my guarantee. Could be wrong. Maybe not everyone, but I'm willing to bet at least 99.5%. So I have a background in strong C++, strong security, strong architecture. I wasn't happy in InfoSec. It was intriguing, it was interesting, but I love the code. I am first a programmer, and I am second a hacker. 15 years ago, when Napster was getting in trouble with lawyers and such, I wrote my first file sharing app called Voodoo Vision. And you'll see the cute little green mask guy right there was the Voodoo Vision demon. And it was a Java-based software file sharing app that worked equally well on Linux and Windows. And it was fairly popular. I mean, it was nowhere near what Napster was. It was a very centralized design allowed servers to cross-communicate and share information. So the idea with Root Vision before I actually put it down was that you couldn't shut it down. Once you start bringing up servers, forever will they communicate and just spread like a very happy file sharing virus. But none of the bad negative connotations of the virus. Well, unfortunately, I panicked when Napster got sued. I was young, I was impressionable, I had no money, and I was very fearful that I too would get sued. And maybe it was a wise decision to take it down. But it's a decision I regret for the last 15 years. 7 years ago, I bought an HD DVD drive. And I wanted to watch my HD DVDs on my computer. So I downloaded the Toshiba drivers, and I was watching my HD DVD, and guess what happened? My monitor at that time, the HDMI plug, did not support proper HDCP handshake. So as the good programmer / hacker, did I just take it? Hell no. What I did is I spent 2 weeks looking into it, and I hacked Power DVD, and I released the very first AACS device key. You can search for Atari Vampire, you can search for that key right there. That's my AACS device key. I was the one who first released it. Blu-ray and HD. Yes. There's a processing key. So I worked very closely with some other hackers, one by the name of Arnazami. He was the first one to release the processing key. Processing key is if keys are rings, and one ring is to rule a ball, the processing key is kind of the one you want, because that's not part of the AAS G3 without boring anyone. That's a little higher up. So if you can hold the processing key, then you can pretty much own the system. The device keys was actually used in the pipeline to do the encryption. So this is one of many device keys that were part of that. I think it was the MKB V1 or V3. I can't remember. It's so long now, but it was at the point where replication was not a normal part of a ACS's process. So I was bored. It pissed me off. I just wanted to watch the video that I bought in 1080p, and because I didn't support a proper handshake, that's my computer. So that's kind of giving you a little bit of background. I dabbled with security where necessary as a hacker. Today, 2 years ago, I started working on DemonSaw. And this is my second file sharing app. I found myself about 2.5 years ago, halfway around the world. And I was there for about 9 months. And I could not have I didn't access all of my content. I couldn't figure out how to access my audio and my video content that I had acquired through legal and otherwise non-legal means. I just wanted to watch the content that I had acquired. I tried Netflix, but because of all these localization rules, I was getting a lot of shows that I wasn't really interested in, but very cultural shows, and I didn't understand the humor or the language at times. So I just wanted my content. And I started to think about file sharing and where we've been the last 10 years. We're going to talk about a little bit about the history of file sharing today. And then I'm going to show you basically the security of DemonSaw. And I'm going to show you how DemonSaw does what no other file sharing does. It allows you to truly share anonymously and securely whatever you want, and nobody can figure out what you're doing, and nobody can stop you. And this is just the beginning for DemonSaw. This is the day of 1.5. I just released it today. In 3 months of DEFCON 23, I will be releasing DemonSaw 2.0, which is not only going to take the client to Linux and Raspberry Pi, but it's going to take it to OS X, and if time permits, it's going to take it to Android. Fingers crossed I can get all that done in 3 months. But not only does it take everything to these 5 different platforms, but it also adds cool features, and we'll talk about some of those features in 2.0. Things like file sharing. Don't like Dropbox, don't like paying for it? You're done with Dropbox in 3 months. Use DemonSaw. Keep your stuff on your drives, do it for free. Securely free. You're done with the cloud if you want to share files. So these are fairly bold statements, and you're probably thinking, the smart people that we are, how's he going to do this? Well, I'm going to show you the details of how I do this today, and we're going to talk about the future and how you can be involved to help all of us achieve our goals of securely and anonymously sharing files. Oops. DemonSaw gave this to me for free. It worked at DEFCON 22. Clearly, it hasn't worked out. All right, so what I'm going to do is, so just to give you a little idea before I jump into this, what's going to happen over the next few hours. Apparently, we have this room until 10 p.m. or even beyond. So there's two parts here. There's the talk, which should go for the next 45 minutes or so. Beginning which I will give away tons of cool t-shirts. The Q&A at the end. I want to make sure if you have questions, you ask me. I'm here until tomorrow evening. Whatever you need from me, I'm here for you guys. So that will be the talk. Once that's over, we'll have about a 15-minute intermission, during which time I'm going to set up this little network that I have. I have some wireless routers, I have some gigabit switches, and I have 3 Raspberry Pis that are going to hook up. So we're going to have a workshop, hands-on workshop with DemonSaw if you want it. We can transfer files through the Raspberry Pis. If you've got your own Raspberry Pi, I can show you how to hook it up. If you've got your Linux, you can hook up the router. If you've got your Windows client, you can transfer files together. We can do whatever you want, hands-on DemonSaw, or if you just want to watch, or if you just want me to watch me play around with my Raspberry Pis, that's okay too. So we're good here. All right. Let's talk about t-shirts. Now, how many of you follow me on Twitter? Okay, all right, a couple of great souls have been into it. Great, thank you. Well, I promised you that I would give away t-shirts, and what I'm going to do is, just so you know, every conference I go to, I print a limited run of 24 t-shirts. That's it. So with DEFCON 22, there was 24 t-shirts that looked like this. By the way, I found this in a room in my house in Italy. It's one of the 24 that somehow I forgot to give away. So one lucky individual who requires an extra large is going to get this today. I also printed 24 of these nice gray DemonSaw 1.5 t-shirts. So some of which I've given to the HackMiami staff, some of which I'll give to you guys today, and others that I'll be randomly giving out the next day. So if you've looked at my DEFCON 22 presentation, which is on my website under talks, here are some questions. I'm going to ask you some questions. There's going to be 8 questions right now. So 8 t-shirts will be given out, assuming correct answers. If incorrect answers are offered, then we could potentially have 8 minus N t-shirts given out. So, first of all, and show your hand if you know the answer. Only one t-shirt per person can do one test. What was the title of my DEFCON 22 talk? Yes? That is correct, and cheating is also allowed. So yes, what size? Okay. Can I have somebody help me hand these out? Okay. All right. So there's only one more large left. I have smalls, mediums, and extra large. So I don't know if that kind of stirs up the excitement a bit. All right, in my talk on DEFCON 22, I defined the modern internet. I talked about the internet that we're currently in and some of the woes and challenges. So I defined the modern internet by 4 different states. Can somebody name those states for me? Somebody name any of the states for me.
I'm downloading the presentation right now.
Next question. We'll review them here. So at the end, maybe I'll have a couple more spontaneous questions. But we'll see them here at the end. Okay. Can somebody tell me, client-server-based network model, what are some of the security and privacy concerns with file sharing through a client-server model? Jump into that.
If the server is being monitored, if all the clients can get in a potentially
Absolutely. What size shirt?
a large
10.
Yes, sir. Answer your second question.
Oh, okay. You got the second question? Okay. You're looking at the answers. Cheating is also allowed. Yes.
State of trust, state of convenience, state of control, state of change.
That is correct. We have medium, small, and extra large.
I'll take medium for the right.
Okay.
Thank you.
All right. So we talked about problems with client-server model. What are the problems with a peer-to-peer model? Yes.
Sometimes you have to be unseated.
Okay, what about security and privacy? Oh, that's more like reusability.
You can have somebody seating who is working for NPA.
Yes, evil people listening. I like it. Okay, what's that third?
Meeting.
I'm just going to throw this at you.
There you go.
Okay, so we have extra large, a couple smalls, and one more medium. This is an easy one. What is DemonSaw?
File sharing.
Right there, gentlemen, right there.
Secure file sharing program.
Yes, all right. Who created it? Just for a bonus.
Isha.
Asshole guy. Okay. All right. What size? Extra large, medium, small. I kind of told you the answer to this, but I want to dig a little deeper. Why did I create DemonSaw? Yes, Lisa Beth.
Because you were halfway across the country and you wanted to get your content.
That's correct. Anything else you can offer? Deeper. You can make it up and it might be true.
It's your hobby. You've been dropping the previous file sharing.
I like all that. Yes, absolutely. What size shirt?
Medium.
All right, medium. So now we have small and extra large. Oh, I kind of told you this already, but okay, I'll make this a two-part question. First part, don't raise your hand until I'm done with both parts of the question. First question is, what platform? That's fine, I don't listen to that. So the first question is, what platforms is DemonSaw on with 1.5? The second question is, what platforms will it be on with 2.0? Yes.
Raspberry Pi.
And
Windows.
okay, and
Linux.
okay, and for 2.0,
You said Android. You're trying to get to Android.
okay,
And Microsoft.
yes, correct. What size?
Small.
Soft.
All right.
is allowed.
It is allowed.
Reserve not such.
Yeah. Okay. Now, this question you might not be able to get, but at the end of the presentation, if you don't get it now, I will re-ask it. This is kind of a super bonus question because the winner of this one can choose between either small t-shirt 1.5, an extra large t-shirt 1.5, or the special 1.0 t-shirt that I found in my garage a couple days ago. Okay. How does security work on DemonSaw? Yes.
Is it with that image authentication?
It's partially true. More.
Unfortunately, that's all I've got right now.
Okay, all right. So you're leading the pack with that answer. He is the gentleman to beat everyone in the room for the special version of the t-shirt. Yes.
We can be by answering the question, though, right? Because I can't take anyone else here to business.
Right. I'll re-ask it in the end. But yes, that is about a third of the answer. So, but I will re-ask that in the end. So prepare and listen. Great. You guys did a great job with questions. Thank you very much. Just so you know, how it's going to work is we've got about 40 more minutes to talk, and then Q&A, like I mentioned, will break. I'll set up the network with you hands-on, and then once that's over at 9-ish or whenever you leave, or 10-ish or whatever, then I will be available to either buy you beer or have you buy me beer, or a little bit of both.
All right.
So hopefully the buy me beer is the more preferable, but I am open to both at this point. Okay. So Sun Tzu, one of the great Chinese generals and the author of The Art of War, once said, "Know thyself, know thy enemy, 1,000 battles, 1,000 victories." The idea behind this is we need to know what we're fighting, we need to know where we exist, we need to know our current landscape. So a history of file sharing, and keep in mind, this is going to be a lot like House of Cards on Netflix, where if you miss season 1 or it's been 9 months since you've seen season 1, at the beginning of season 2, what do? They quickly recap 13 episodes in a span of 3 minutes. The first 6-7 slides of this presentation are really a Netflix recap of season 1, which I did at DEFCON 22. If you want to see that full presentation, go to DemonSaw.com, go under Talks, click on DEFCON 22, and there's links to the YouTube video, or you can look at the PDF, or a little bit of both. So the history of file sharing is one of the things companies don't want us to know is that the internet, years and years and decades ago, was founded on core principles that are important for file sharing. So when you really look at how the internet works from a TCP/IP stack perspective, so you've got your Ethernet level, you've got your IP level, and you've got the various application stacks, you've got the entire TCP/IP stack. It's all about endpoint connectivity. It's all about separating responsibilities and layering and modularization of different parts of the data. All right? So message and data exchange and endpoint connectivity and reliability and guaranteed delivery and all these things are core to the internet, and they're also core to file sharing. When you surf and browse a website or you send an email, all you're really doing is sending a very, very small, potentially large file. Because all a file is a string of ones and zeros. And all a message is usually a smaller string of ones and zeros. So when DemonSaw talks about secure file sharing, what we're really talking about is securely sharing ones and zeros, be it messages or be it gigs and gigs of data files. The abstraction of the underlying protocols and securing that transmission through higher level encryption like HTTPS, using SSL or TLS, these are all things that file sharing also shares in common. So it's all one and the same. And there's plenty of examples out there where we have protocols and applications where file sharing is core to what they do. You want to read through this list? Oh, by the way, this is a funny 80s graphic. You guys maybe remember this? I vaguely remember this. It was one of the stupidest marketing campaigns ever. But it was, there are YouTube videos in case you missed this. I don't know, like somewhere in the 80s, but they're really lame. And they're funny if you want to get a good laugh. They were serious about this too. There's even rap songs. It's really lame.
Copy that file.
Yeah, it's really now file sharing in today's right now is under siege today. Technology enables us to do a lot of extremely powerful and amazing things, but the standard model for business has changed over the last 10 or 15 years. And so organizations like the MPAA and the RIAA and studios and production companies are really have led a witch hunt in the last few years to hunt down people who want to share their content freely and securely and without consequence. They want to box us up and define how we use the content that we pay for, even legal stuff. Doesn't matter. And then they try to offer solutions like ultraviolet or other mechanisms that are wrapped in draconian DRM and handcuff us to some sort of restrictions that don't work, like HTTP handshakes failing on my computer monitor 7 years ago. So no matter what they offer, it's not good enough. They don't trust the paying and honest consumers. And this is frustrating for me. This is frustrating for us, and it's not right. We shouldn't be treated this way as honest and paying consumers. We can fight this. We can change it. Now, the reason for this is, there's a lot of reasons for that companies do this. I think a lot of times executives don't understand. They don't have our knowledge. They don't have our zeal. They don't have our passion. But also, I just think they become afraid. They're very comfortable where they're at, and change is a fearful thing for them. And fear leads to panic, fear leads to misjudgment, and fear leads to mistakes, as well as witch hunts and bad decisions. And so, the file sharing wars began really at the start of Napster. In fact, one could argue it went all the way back from, the don't copy that floppy rap and all that. But really, witch hunts started with Napster, where we really saw a lot of it. At least that's when the media picked it up at that first time. And so we've suffered many casualties in the past 5 or 10 years because of this approach by these organizations. Napster, Aaron Swartz, Julian Assange, RapidShare, GroupShop, MegaShare, Demonoid, Pirate Bay, other torrent trackers. It's removing Google links. The list goes on and on and on. And a lot of these are recent, like what Demonoid did just to get to block ad block. So you go to Demonoid and you don't have ads enabled, you're blocked now. So you have to think, why do companies do this? Why do companies feel like they have to approach it this way? Because they're losing money. They're providing a service and they're not getting money. And funding's important for sites like Demonoid. So having to resolve or resort to these type of scenarios and these type of angles is really an indication that something's wrong with the model. And so what we're seeing here is things aren't right. So a lot of people groups like the MPAA and the RIAA are leading this attack. So we have it's not necessarily meant to just beat the shit out of the MPAA and RIAA, but that's how it's going. So we're just going to roll with it. So we have a difficult journey ahead of us. We really do. As ambassadors for file sharing and the right to share. We need secure message and data exchange. We need it for a variety of reasons. We need it because we can't trust governments, and we can't trust corporations, and we can't trust third parties that embrace the draconian policies of our government, things like the Patriot Act, things like the Snowden revelations, and the list goes on and on and on. We just can't trust people. And honestly, it's none of their damn business what we share. It really isn't. So we need a mechanism to stop them from knowing that. We can achieve that. You see governments now denouncing encryption, like in the UK. Silly things going on saying, we want an encryption, but we also want the ability to have a backup. Well, the ignorance, the level of naivete, and just the foolhardy nature of saying such a thing is evidence that they clearly don't get it. And they don't have the right people on their staff to help explain it to them. So that inspires me as a programmer and as a hacker that we have to teach. So the ignorance that governments and corporations have is empowering us to do something different. The voice of the people will be heard. File sharing is one of the few technologies that doesn't require a middleman anymore. And that's why governments and corporations are so adamant to shut it down and to change it. Because they're afraid of it, because they don't have the control over it. The NSA and other government organizations are truly afraid of us and our ability to change the future. Fair use is pro-privacy. Technology, I believe, will set us free. I watch a lot of documentaries. So I describe myself as casual Dropbox user with an addiction to torrents. That's kind of how I describe it. It's probably not a good description. I should stop saying that. But I watch a lot of documentaries on Netflix. And one of the things that amazed me recently was I was watching the War of Independence against the British. And one of the things that changed the course of the war for us, we totally outnumbered. We should have lost 100 times over. We had a new rifle. We had a new rifle that had a curved barrel. I forget the exact name of it. There's somebody who knows guns and history better than I do. You know what it is. Basically, when you shot it, it was an American-made rifle. It actually spun the ball, and that created a rotational effect, which made it more accurate. So technology in that case gave us an advantage. And technology as hackers and programmers will also give us that similar advantage. Technology has always been the decisive factor between failure and success, or between survival and extinction. And it will continue to be that. So there's a file sharing singularity right now that is just beginning. You can feel it. You can feel the tingle in the air. You can feel things changing for our generation. The old generation from 20 years ago or 40 years ago did things different. But our new generation, our modern generation, we have a new approach and a new way of looking at things. And so we're going to have new needs for file sharing. You can feel the change in the air as we start to become experts in our 20s and 30s and 40s. Ray Kurzweil speaks about this singularity, where there's this one point in time at which artificial intelligence reigns. There's a file sharing singularity that I believe we are right on the cusp of. We are at the event horizon about this subject. Edward Snowden, a man I would love to meet, said that encryption is the defense against the dark arts, and he was absolutely correct. Encryption and technology will set us free. So let's talk about the modern internet. Hey, there's 4 states that define the modern internet. Trust, convenience, control, and change. Now, I talk about this in detail in my DEFCON 22 presentation, but basically here's how it works. And it's affecting all of us right now, and we can't stop it. And it's a sad thing, but it's a true thing. We trust companies like Google, Facebook, and LinkedIn, and Microsoft, and the list goes on and on and on, like Twitter, etc. And they give us extra convenience. They give us this super convenient, heightened, single sign-on, interoperable experience where ads are catered to our interests and everything is comfortable in one place. And we love it. We love it because we can do everything on our phones. We can order everything from Amazon. We can do cost of convenience is control. Because when we give up our data and they give us convenience, we give them the control of everything that defines us. And our data now is no longer just an aggregate of insignificant details about our lives. Our data, aggregate data that these companies collect and share with one another, now defines us as individuals. It's so much data, they don't even know us in real life. They know who we are and what we're going to do based on our data that we collected. Now that's a scary thing. So the fourth step to the modern internet is really change. We are at the precipice of change if we embrace it. We can change it if we want, or we don't have to. I believe in changing. I don't want to continue down this path where our privacy and our security are constantly at risk. I feel we can do something different. So the truth is, and you don't have to keep this to yourself, but the truth is convenience doesn't require trust. So as much as these companies want us to believe that we have to trust them and give them our data to have this level of convenience, that is not true at all. In fact, we can have the same or greater level of convenience by not trusting anyone. So one of the core ideas behind DemonSaw is trust no one. There's no centralization, there's no third parties, there's no asymmetric encryption, none of that. It's all about you are the only person you trust. So why is it so difficult to make file sharing secure? Well, let's talk about security. We've been stuck in a security model for the past 20 or 30 years that is catered toward governments and corporations and entities that require trust. So let's talk about this a little bit more. All right, companies, how do they do business with one another? Well, they need a mediator. They need a certain authority, or they need a verisign, or they need a mediator of trust by which they can tell their customers, hey, this search is good because such and such verified, right? So the model of interoperability that empowers modern commerce is a model of trust, and it can't live without it. You can't have the decentralization of security and have our current world and our current internet function just like it has. So you need asymmetric keys, you need key stores, you need certificate authorities, you need all of these things, the centralization of security. So the standard models require trust. But security is a lot like water. I bet you never thought anyone was going to compare security to water, right? Let's walk through it. So water should be free. We need it to survive, and it should be free. But governments try to regulate it, and companies try to bottle it up and sell it back to us at a premium. This doesn't need to happen. It should be free, and it should be free for file sharing as well. So the standard methods of security are very complex. All right, self-signed certs are kind of frowned upon. Replication lists are tedious to maintain, etc., etc. Now, the problem with file sharing, there's a lot of them, right? I would ask you who shares files in here, but that sounds like a very personal question. So, who doesn't share files in here? All right, a much better question. The negation of one is not necessarily the opposite of the other. All right, so file sharing has historically been easy. There's no question about it. Either you have apps that don't have any security, and which I don't know is the best form of security or lack of security. I don't think that's true. It doesn't even sound plausible in any alternate reality. We can't trust client server. We can't trust peer-to-peer because our IP is revealed. So one of the things I said last year at DEF CON is inadequacy breeds innovation. What does that mean? Because everybody loves Bitcoin and peer-to-peer, they don't love getting notices from their ISP that their internet's going to be shut off. I mean, I don't like that. You don't like that. What we've done is we've created this niche market for companies to create services like proxies and VPN and PeerBlock and Tor and all these kind of extension technologies that solve the symptom of peer-to-peer networks. They don't actually solve the underlying problem. So we tag on these band-aid solutions that work great. There's nothing wrong with Tor. There's nothing wrong with Tor. There's some things wrong with PeerBlock, but it is free. But you get the idea. There's nothing wrong with VPN. I have VPN that I use for not enough. File sharing was founded on antiquated and outdated technology. So when you really look at file sharing, it hasn't changed much in the last 10 years, right? Look at what's happened ever since BitTorrent was produced. Not much. The cloud was created, right? We have Dropbox, we have Azure, we have Amazon, we have, whatever the Apple one is. I don't know what Apple is, I don't know, but the cloud's everywhere. We have too many clouds in this world right now, and it's growing and growing.
It's making things gloomy.
So I'm sorry?
It's making things gloomy.
It is.
To the clouds.
It is. Nobody likes a cloudy day, right? I'm probably going to be quoted. I watch. Some media outlet is going to quote me on that last thing. So why haven't we changed the last 10 years? Well, it's not a simple question. It's not a simple answer. Basically, I think it's a combination of a lot of things. I think it's been enough with BitTorrent. I think part of it is complacency. I think part of it is just there hasn't been an evolutionary leap forward in file sharing technology. The solution is we need to make file sharing secure. We need to do it. We need to do it in a non-peer-to-peer. We need to do it in a non-client server way. So we need all these things here. We need secure message data exchange, anonymity, access to private and public content. It can't just be I have an FTP server hosted at my IP. Here's my 3 friends who have access to it. That's not the file sharing we need. That's fine, but that's not what we need for millions of people out there. We need to be scalable. Now, I'm not talking scalable just in the sense of have features. I'm talking scalable from a core architecture concept. So I'm talking millions and millions of users. I'm talking the lack of white papers on technologies like BitTorrent, on what happens when you add too many nodes to a BitTorrent network. I don't think the performance of a network should degrade with the number of users that you have. Now, if you think about it, that's a fairly bold and ambitious statement, right? With the BitTorrent network, you add more and more and more nodes, and the network can eventually degrade in performance because the ratio of download, which is the content acquisition, from the upload, which is the content aggregation, is going to slide to one side. And also, you have extra network traffic due to leaf nodes and stuff like that. We need a file sharing solution that there's no link between performance and number of users on the network. Most technologies don't have anything near that. Most architectures don't have anything near that. And we can't have peer-to-peer or synchronization. So we need to reinvent file sharing. We need a modern approach. And so let's talk about my little idea that I've been working on for the past 2 years. Sometimes it takes a revolutionary idea to start a revolution. I believe that information should be free. I believe in the right to share. I believe in empowering all of us, enabling us to share freely and without consequence. What is DemonSaw? Well, you already guessed it. You already won your t-shirt. It's a secure, anonymous, free, everywhere file sharing app. Now, one of the things that I already told the HackMiami team, and by the way, you guys are getting a lot of content and things that I've never told anyone before. And it's only because I love this group so much, and this group is very kind of open arms in accepting me and understanding what I'm trying to do and supporting me. So let's talk about the name DemonSaw, all right? So I'll tell you the etymology, or I'll tell you what I tell publicly where the name came from. It's a cool definition. It's not really true. And then I'll tell you the real meaning of the name. So you have 2 definitions. Go with the one you like the most, because that's what I do most. All right. So how many of you are familiar with We Are Legion or We Are Legion for We Are Many, kind of the anonymous slogan and all that? Okay. Do you know where that comes from? Sorry? It is the Bible. It's Mark 5:9. And there's a verse in the Bible. I grew up in the church, so I'm not quoting any Bible verses to try to turn anyone. I don't go to church anymore, but I have these years of church knowledge that I feel I must use, or it's just wasted brain cells. So in Mark 5:9, Jesus asked the demon, "What is your name?" He says, my name is Legion for the earth. Well, if you look a couple verses before that, in Mark 5:6, so if you look at Mark 5:6,
wrong, but it's the wrong mic stand for the job, everybody. A real mic stand.
Okay, I must project, Alex says. If you look in Mark 5:6, it says, and I think this is the new, not the new international version, it's the new light version. All right, new light version, a different Bible. It says, when the man with the demon saw Jesus. So one of the reasons why I chose the word demon saw is I wanted to thank and kind of tip my hat to a lot of the work that our anonymous allies are doing out there. And so by choosing a Bible verse that was close to the we are legion for we are many, I felt that was kind of an interesting way that I kind of let them know that I appreciate all of their hard work. Now, the real reason. If you look at DemonSaw, what I wanted to do is I always thought demons were cool. Right? I mean, who doesn't? They're cool, right? I kind of like aliens as well. So I wanted to name my app some sort of convergence between demons and aliens. And so I thought I'll use the word demon. What I also wanted to do is I wanted to send a clear and unmistakably pointed message to groups that are doing bad things and doing illegal things in our country and in countries and in other countries. Organizations like the NSA. I wanted to let them know that we don't appreciate and we don't like what they're doing. And so I chose the name DemonSaw because embedded in it, it has the letters NSA. And so I wanted to let them know that they are on our radar and they are in our thoughts. And a lot of what we do is because they're doing stupid things that we don't like. And so that's the real reason. Alright, well, so DemonSaw is secure, it's anonymous, it's free, it's everywhere. Alright, it's designed to protect our identity and hide our actions. I want to review a couple of terminology things really quick. There used to be a client, a router, and a server. In 1.5, I deprecated the server because it wasn't necessary, it was a little confusing. What the server was it was a subset of the router. Basically, a server was a router that just did data transfer. Well, in 1.5, what I've done is I've enabled the router to do any number of things. You can use it for message aggregation and linking clients, or you can also use it for data transfer. So how you configure your router is totally up to you. So there's no more need for a server. And of course, the client is basically a downloader or an uploader, somebody who shares content. There are two versions out there right now. There's version 1.12, which is the C# version that is slowly being deprecated. The C# version will totally be gone in 3 months with the release of 2.0. There's also 1.5 that I launched today, which is all of Linux, which includes the router on Linux, command line, and GUI. It includes the router on Raspberry Pi, command line, and GUI. Those GUIs are really important. That's what kept me up so many nights. And it also includes the command line and the GUI router on Windows. So all of those are C++ complete rewrites of DemonSaw that I've worked on the last 9 months. The only C# apps that still exist today in 1.12 are the clients for Windows, the 32 and 64-bit, as well as the web server, which is a deployable router that only does data transfer for .NET Web apps. So for DEFCON 2023, I'm going to be releasing 2.0. Now let me show you right now. I'm going to do a quick demo. We're going to go into a lot of detail in the second part of this in the workshop. But what I want to do right now is just show you 1.5 and 1.12 working together. We're just going to transfer some stuff locally, show it in action, and just kind of get you really excited about the next session. See if I can not break this.
Yeah.
Okay. All right, so this was the old router. I I had this on the 192.168.0.1 because I haven't hooked up to the router. I'm going to have to switch back to 127. So they'll be read a little bit and we'll switch to grade. This was the old router. All right, it's OWPF C# GUI. It's still downloaded today. It's at the kind of legacy downloads way at the bottom of the page if you want. It was complicated for a variety of reasons. You had the routers tab, and below you had these servers that linked to the routers. So if the router wanted to use other routers for data transfer, you put them down below. But then if you wanted a server locally rather than a router, so you wanted a router for data transfer, you had to put it in the server tab. Confusing, weird, not cool. So we removed that. What I replaced it with was brand new UI and brand new command line. We're working both right now. So when you open up the new 1.5 GUI, everything is based on simplicity and quickness and to get you to your content as fast as possible. When you start the GUI with the router, and by the way, you don't have to use the GUI. You can use the command line. But we're going to use the GUI first to auto-generate the new XML file, and then I'm going to show you how the command line works. So you just click on the plus button. Boom. Now I have a router. What I do is I'll configure it. Okay, 127. I'll enable it, and we're online. I'll go ahead and save it. Okay, so now we have established a router on 127.0.0.1. What this will do is this will service message requests to any client that connects to it. There's a couple, the way I designed this, I designed the new DemonSaw GUI to basically cater to the needs, basic to advanced of the users. So rather than having the app shout 1,000 things at you and varying features inside of convoluted menus, what I've done is I've allowed you to customize it. There is a, and I kid you not, there is a CSS file where the executable runs that you can modify to your heart's content. So if you don't like my ugly 00D087 hexadecimal green for the DemonSaw green, you can change it. All right, it's a Qt. Oh, excuse me, I always call it Qt. It's a Qt. So anybody who's also a Qt developer out there, please don't hate me. It's a Qt GUI. So the Qt CSS is a subset of normal HTML or CSS. So there's a lot. It's very, very similar. You can go in and you can just rename demonsaw.css.text to demonsaw.css, modify it, and the GUI will pick up your changes instead of using the internal ones. So customize the look and feel, customize the colors. If you create a much cooler color scheme than I have done, and I almost guarantee you everybody in here can do that, please let me know. Please send it to me, and I will bundle it in future releases. Play around with it. So what you can do is in the view menu, there's different options. So you can show the toolbar. You can show the menu bar, which is basically quick commands to the menu. You can also show the detail. Now the detail pane is basically going to contain errors here. So any errors in the routers, like maybe a bad handshake or some sort of cryptographic error, maybe you're trying to bind to the same socket, same port on same ports on two different sockets, etc. You get error messages here. One of the problems with DemonSaw 1.12 is it didn't really tell you. It gave you a little evil red icon, and that's really it. It kind of just yelled at you, and it wasn't very friendly. This gives you the scripted message here that you can then screenshot and tell me what's going on. Then there's also this beautiful option. Now what I've done, there's no pop-up boxes, there's no right click. There's none of that in DemonSaw 1.5. If you want to configure the options, you just bring up this option key. And all the options are right here in a nice little toolbox. So I've totally deepened the experience. I'm giving you the ability to change options that I've never exposed before. Keep in mind, this is only the beginning. 2.0 is going to take us to the next extreme. So you can change different timeout values for the router here. You can change the number of seconds that it will wait to restart in the event of an error. Like somebody connects and gives you a invalid handshake value or something. So you can go super, super low level. And what I'm going to do is I'm going to write some video tutorials in the next few weeks that goes into kind of what all these are, when you want to tweak them. If you don't know what they are, don't worry about them. I set them to decent default values that should work for most of the time. Protocol tab is really awesome because now what you can do is you can enable or disable individual messages. So if we want this router to only do data, we simply disable everything but transfer, download, and upload. Transfer is the file request, the download and the upload, or the upload and download request are done. This is now a data router. It will only do data routing. Some of you have probably noticed that little chat box down there. Yes, I'm launching Secure Chat in DemonSaw 2.0, and yes, it is secure. And it will be available here as well. And by the way, all this is downloadable now from DemonSaw.com. So you go to the download page, you can download this on Linux, Raspberry Pi, and Windows, and play with this now. We're going to re-enable this because I'm going to show you a quick demo. If you don't want to do data, you only want your router to do messages, you can simply disable these three. So the inverse of that. And now nobody will ever transfer data. So you want to host your message router at home, but you want to use ISPs to reroute your data content like I do. You know, might as well pay $4 for a hosting site a month to send all of your data. Last month I sent 50 gigs of data through my web host that I pay $3.50 a month. They're very kind people.
Very ignorant.
Yes. And then finally, there's some network details, like the size of the chunk, 128K. If you've got a wireless network and you've got slower network, you can increase that to like 64, 32K. The buffer is how many chunks, the total memory of combined chunks for a given transfer around full memory. So for every transfer request here, this guy will hold in memory up to 8 megs, or 8192K. And then the drift is kind of how far off from the lowest byte that you'll go. This is mainly for streaming. If you're downloading something and you also want to stream it at the same time, you don't want your drift to be too far, otherwise you might get choppy playback. Oh yeah, did I mention streaming is part of 2.0? But I'm gonna figure out a way to find time to write it. Streaming could be part of 2.0 as well. And then some other stuff as well. Alright, let's save this and let's go the old clients. Alright, I'm going to edit this. Going to restart it. The reason why I'm doing that is the old 1.2 version only saves upon shutdown. So if something happened, we have to retype that 127.0.0.1, and I'm terrible at typing, especially when presenting. What we have here is I've set up a couple of clients. Now this is just a test. Pretend that the home and the work clients are actually like different computers. If you want to test DemonSaw with yourself across the network, you set up 2 clients and you put up a router. So in order to securely file share, all you have to do with DemonSaw is you have to put up a router and you have to put up a number of clients. That's all you do. You become your own private file sharing network. So what I've done here is the home client has no files that it's sharing. And the work client is sharing a bunch of cool music. So if you want to switch clients locally, you can use this drop down. And by the way, this is the confusing old C# GUI, which is totally going to look cool like the new router GUI that we saw a second ago in about 3 months. So it's totally retrofit this. The way that DemonSaw security works is this little image right now. Now we're going to talk about how I'm taking that about 20 times greater in 2.0. We'll talk about that in a few slides. But for now, DemonSaw has multiple layers of encryption. So you've got your HTTP packet, you've got your message that's encrypted for a client to a router. And then you've got your data, which is encrypted from client to client. So when a client wants to download data from another client, it doesn't do so directly. It sends those requests to a router. But the routers, whether it's a message propagation router or a data router, doesn't need to know what the client is actually requesting. So anything specific to clients is encrypted so that the routers can't see. The routers don't know what you're doing. So even if you compromise all of your message and data routers, nobody knows what you're doing. Nobody knows what you're sharing. Nobody knows what you're searching for. And nobody knows what you're downloading in general. Now with 2.0, I'm going to try to enable HTTPS so we can get rid of the threat of DPI. So that's something that I've been looking into. It would be really easy for me to support self-signed certs to completely rule out the possible any sort of deep packet inspection or any of this. And that would make it even cooler. Because now if you compromise the routers, they have no idea even what type of data you're sending. As it stands, you could potentially analyze it and say, this looks like IO data, even though it's encrypted. But with HTTPS as a wrapper on top of that with self-signed certs, not VeriSign signing, not central certs, signed certs, you could basically have all this DPI inspection routines have nothing to do. It just bypass it. And by the way, in case you want to know, I use DemonSaw every day to download content from home to work. I download stuff all the time, and it just goes right through. The network at work has no clue. And I work for a pretty big company, and they never notice anything because it's all HTTP traffic. So it's now you could also use it. What's that? You could also use it for uploading stuff from work. Also not knowing, I don't do that because I like my job. But theoretically, you could do that. Yes, sir.
So you described that feeling data.
I-
Encrypt that.
Yep, I definitely will. I have a slide dedicated just to that. If you don't mind, I'll wait. But and if that doesn't answer your question, please jump in at that time, and I'll go deeper. Okay, so let's transfer some shit. All right. So I am the home router right now. Pretend like I'm only the home guy. So I just searched for ACDC. Now keep in mind, this is how fast it is. This is real life. If you use DemonSaw, this is real life. I always like hybrid help. So I just downloaded hybrid help. Now keep in mind, a little disclaimer is I'm transferring locally, so it's going to be super duper fast. But DemonSaw 1.5 and 1.12 is written in a very serial way right now. Now, what that means is when you request a file, like I just requested hybrid help, and if I were to play this, it would play properly. That's it, got the whole file. But it's a one-to-one relationship right now. So I go to my message router and I say, here's this encrypted block, forward it on to all the other clients in my group. All you know is it's a search. You have no idea what I'm searching for. The clients in my group get that, everybody but me, and it decrypts it with the key derived from my group image. So the entropy for our encryption routines is the unique byte pattern in our image. And so that's the cool thing about DemonSaw is we no longer need asymmetric encryption anymore because the contextual awareness of our social interaction defines points of entropy that are shared already. This just happens to be an image that these two share. And if you look here, these are the two images. They both have that image. These images can be local. In 2.0, they can be online. And in 2.0, they don't have to be images. They can be any URI. They can be a PDF. They can be a website. They can be anything. And not only that, they can be any random percentage of bytes in that resource. And one more thing is you can have many URIs strung together as a composite key of entropy. And even more, you could set it to auto-mutate and auto-update the key. So if anybody happens to find out your URIs, they don't know your percentages. They don't know how quickly you update. They don't know your algorithms or your key sizes. All these things you'll be able to set in 2.0. And here's the cool thing. I was talking to my mom the other day. She is not technically savvy. She knows enough about technology, but when I start talking about cryptography, I tend to lose my family members most of the time. And so I was talking to my mom, and I'm like, she doesn't like remembering passwords. And so I did a little kind of thought experiment with her. She didn't know about it, but it worked for me. So what I said is, she's like, oh, what is DemonSaw? And I'm like, okay, Mom, I'll tell you what DemonSaw is. Okay, so I give her the high-level overview. And then what I said is, do you use a website? She's like, oh, I use my university website. Okay, every day? Yeah, okay, so let's take that. What's that website? www.university.gov. Okay, now you remember this all the time, right? Yeah, I do. Okay, so what's your birthday? Month/2 days. Okay, all right, you remember that all the time, right? Yes, okay. Now, what if I told you never have to remember password again? What if I told you that all you had to remember was your university website that you type in every day you get into work and your birthday? And it would be just as secure, if not more secure, than having a password. And so I waited, she thought about it, she's like, yeah, I like that. And then I said, now, what was that university website again? She told me it. What was your birthday? It is, just for the sake of this presentation, I'll say 4/1. All right. Okay. So 41, say 55 or whatever. Okay. So 41.55% of the bytes of university.gov we're going to use as entropy for an AES 256-bit key derivation. Done. No more passwords. Mom can securely share it. So that worked really well. Mom was happy with that. But I think I lost her after that. So let me show you here what we can also do. We got some Daft Punk. Now what we're doing here, and let me show you what's going on with the router. We're downloading a bunch of shit here. Alright? So you'll see the router's transfer pane. We're sending data through the message router right now, which is an option. We can do that. But we can also send the data through other routers, and we will do that in the hands-on later. 2 of the 3 Raspberry Pis will only be doing data transfer, and 1 will be doing message transfer. But you notice what's going on is one guy's uploading, one guy's downloading, and all the content is encrypted with the key derived from the group image. So if we go to the work guy and we look at his uploads, he happened to share 100% of all the files. If we had 2 clients that were uploading that have the same files, each of them would have a range between 0 and 100%. It's not direct 50-50 because there's some packet kind of duplication as they're uploading. So there might be an extra 3 to 5% duplication. And you got a third and a fourth and a fifth. So the idea is you add more and more clients. They each upload basically 1 over n, where n is the number of clients. And there's some slight overlap. DemonSaw 1.5 has 1 data router that does all the transfer. So you have n number of uploaders uploading to this 1 data router and 1 download. And so you got a queue going on. And it's serial. It's a little slow. Did I mention that DemonSaw 2.0 is going to allow you to have n number of data routers and n number of threads available for a client at any given time? It will. Why is that important? Because let's say you pay $50 a month for 10 web hosting accounts that are $4 each. And each one of those, you put a data router. Now you have 10 data routers on a shared environment that costs you next to nothing. $50 is a lot, but when you think of having 10 servers at your disposal at any given time, that's pretty inexpensive. Now you have 1 message router that sits on your Raspberry Pi connected to your Linksys physical router at home, and you have your closest 2,000 friends from your university using it. All right? Your ISP doesn't know what's going on because the Raspberry Pi, it's a quad-core Model 2B, so it's a fairly beefy $35 piece of equipment. It's more than capable of handling all that throughput. While the 10 hosted environments take care of the heavy lifting, 99% of the throughput. They never know because it's HTTP. Now, what if the firewalls get smart? What if they're looking at your 128 chunks attached to your poster plus? Good question. All right, so I bet I have a solution to that. Yes, decrease the chunk size. Let's make it 4K. Let's make it 8K. What's the cutoff tolerance at which their firewalls and their network intrusion detection systems no longer care? All right? So you can decrease the chunk size if you're getting performance issues or if you're getting some sort of like ISP feedback. But what about the whole throughput? What if they're sending 50 gigs of data through each one and somehow they figure it out? Well, that's possible, right? I don't know, pay another $50, add 10 more. The message router will do a round-robin approach to shift your data around. But you get the idea. For a relatively low amount of money, you can create this huge secure file sharing network. $100, $200 a month. It's very difficult even to get a decent quad-core or 6-core dedicated server for $200 a month these days. And 1 server is not going to trump 20 shared hosted environments that can handle 50 gigs of throughput or more. So with this technology, you can spread the love, as I like to say. That's a really, really quick demo. We'll get a lot more in-depth later with the Raspberry Pi stuff. For now, though, let's go back to the slideshow. And let's look at... Sorry, I very rarely use PowerPoint. And the more and more I use Linux, the more and more I hate Microsoft products. Is that normal? Right,
Yes, it
okay.
sure is. What?
Okay. So let's take a look at file sharing networks right now. The The client server and peer-to-peer and the DemonSaw models. With DemonSaw, I didn't necessarily invent it. So it would be great if you left here thinking Ija is one of the smartest people I ever met. But the reality is I'm just like everybody else. I'm just another programmer. I'm just another hacker. I'm just another guy with an idea that's standing on the shoulders of giants. Very smart giants. The client server model has a little warning sign there because, as you guys accurately stated, they're logging, they own the content, you don't know what's going on, there's innocent backdoors, there's a lot of bad shit happening at that node. The peer-to-peer model, most of the nodes in the network might be friendlies, but there's going to be a couple of really baddies out there that maybe are monitoring and logging your IP. Not cool. The DemonSaw model is totally, takes both models and it kind of merges them and then smooshes it again. And so what it does is it takes the idea of a server and it renames it to a router. There's no such thing as servers because servers house content, they're authorities, they make decisions. All the DemonSaw router does is really one of two things. Either it forwards messages or it forwards data packets. It doesn't make any intelligent decisions at all. I mean, maybe you could argue it's fairly intelligent, but it doesn't decide for its own. And so by limiting the decisions that are done in the router nodes and forbidding them to know about what the clients are doing, we're able to achieve this level of security.
Still strong.
Last year at DEF CON 22, I talked about these 5 tenets of secure file sharing. So if we were going to create and reinvent file sharing, create a brand new way of doing it, we really have to look at 5 different tenets and embracing those tenets. One is we need to reclaim the authoritative source. What is the authoritative source? That's our data. That's our data that we trust companies to house, and they give us convenience, and then they take over the control. With file sharing, we need to take that back. We can't put our stuff in the cloud and share it that way and expect to be secure. So by us hosting our data locally, we reclaim the authoritative source. Stateless authentication is this idea that we don't need a centralized authority for authentication. Whether it's a key store or whether it's some sort of some open ID authentication model or interoperability, we don't need any of that. We can do it ourselves through automatic key derivation by using as entropy our kind of shared knowledge. Layered and modular security is the idea that compromising any number of the nodes should not reveal what's going on. So if we compromise every single node in a network, well, yes, he's going to have full control. But it's very unlikely that a file sharing network is going to have every node compromised. And if it does, chances are they've owned your machine for a long time anyway, and the last thing they're going to look at is your file sharing usage patterns, right? That's my thought. So layered and modular security is the idea that you take these 3 areas of file sharing. What are these 3 areas of file sharing? Every file sharing app in the last 20, 30 years has had 3 really defining areas that it's dealt with. One is the authoritative source. You have stuff that gets downloaded or uploaded. The second is you need somebody to propagate messages and link clients. You need torrent trackers, per se. You need somebody to kind of connect people. And number 3 is you need somebody to transfer data. So somebody has to have the content, somebody that has to propagate the messages and connect the individuals, and somebody has to transfer the raw data. Every file sharing in the last 20 years has combined 2 or 3 of those together. None of them has kept those separate. What DemonSaw does is it keeps those separate. By forcing those to be separate, clients are the authoritative source. They upload and download. Message routers propagate the messages and group clients. It's all they do. And then routers that are set to do data transfer, all they do is data transfer. Now you can merge the routers with DemonSaw, and the reason why I allow that is just because small file sharing networks at home with few users don't really maybe not benefit from having an over-complex network. So I allow the data and the message to be merged only for sake of simplicity, but for large networks it's best to divide them up because you get that extra layer of security. So this is what layered and modular security means. Distributed endpoints. What this means is that we should be able to spread our file sharing network all over the globe and scale horizontally. We should not have any performance or growth impact by those our data routers and dispersing them as tens of thousands of nodes all in the world, and having our message router do very, very little computation, we can have large groups of people connect to large numbers of message routers and then spread the downloads across n number of servers. And as the clients increase and the downloads and uploads increase, we can add yet more and more nodes without impacting the router topology at all. So this also means that we should have this available on every platform in WFS. So one of the things I've been hard at work for, as you know, is the last 3 months, basically all I did was code command line and GUI DemonSaw 1.5 for Linux and Pi and Windows. Basically, that was my mission. Every morning at 6 a.m. I got up, and that's what I did, and that's what I did on weekends. And it was a pain in the ass to get it working on Raspberry Pi. I spent all last weekend fighting compiler and segfault errors only on the ARM chipset because of C++ 11 smart pointers and bad weak pointer references. So I don't know why ARM just didn't like my code. But now ARM seems to be fairly happy, so which is good. I think it's going to be trading in the end. So there's probably if you get a crash on Raspberry Pi, let me know. That's why I'm still calling it a beta, because I have a feeling it still doesn't like it. And then finally, standard protocols. One of the worst things we could do is invent our own protocol. So rather than that, let's use HTTP. Let's use JSON. Let's use XML. Let's use standard TCP/IP. Why? Because they're free, they're readily available, and we can leverage existing web servers and hosting companies to host DemonSaw routers. DemonSaw works over standard HTTP posts. So what you can do with a DemonSaw router is you can deploy it on top of a website that you already have. Like I can take DemonSaw.com, which services HTTP GET requests, and I could install my DemonSaw router on top of that, which services the HTTP post requests. And you could service through your web browser all the gets, and through the DemonSaw client all the posts, and they can work together. And nobody would ever know you have a DemonSaw router. And that's a benefit of this. And finally, the protocols. It's easy to add new messages in the protocols, such as the chat message that I'm adding to 2.0. But now I'm enabling you to disable things at will if you want to tweak the network. So let's talk about basic messages and the flow. And then just so you know, then we jump into network, and then we jump into content isolation, which is kind of the winning slide. Basic messages is everything starts with a handshake. So the first thing that a client and a router does is it does a handshake. And this is a key derivation through Diffie-Hellman, which is a very common cryptographic algorithm that's used by a lot of different stuff, such as WPS, as well as tons of other security infrastructure components. So right now, it's a fairly simple 128-bit key. With DemonSaw 2.0, you're going to go as big as you want to go. So you're going to be able to tweak your key size. You're going to be also able to add salts and stuff like that through all the algorithms. Right now, I started simple. With 2.0, it's going to increase the security. So you're going to have the full ability to scale up or down and balance performance with security as you need to. Once the handshake is complete, a session key is created. So that shared key that is never exchanged over the network that Diffie-Hellman gives us is used as our AES session key, which is what I call it. And that session key is used to encrypt all the messages right below the HTTP level. So everything wrapped in the HTTP data section is encrypted by the session key. So if let's say Francisco and I are in our own little group, and the router's over there, and I happen to do a man-in-the-middle attack because for some reason Francisco pissed me off, and I was like, I'm going to sniff his data for some reason. And I looked at his traffic, I wouldn't be able to encrypt his session data because he has a completely different Diffie-Hellman-derived AES key than I do. So that extra layer of encryption really protects group members against group members. Why? So you don't get poison messages and stuff like that. Next, for message routers, there's a join function. Why? Because clients have to get grouped together, right? But the router shouldn't know anything about our group key or our image, the key derived from our image. So how do we do that? It's really, really simple. When a client chooses an image, an AES key is derived from that entropy within that image. And then a simple token, a well-known simple token, I think it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, is encrypted with that key. And you have this kind of encrypted value that's used as a key in a map, and that's how the clients are grouped in the router. something that gets the same result and there's some sort of collision. Now these are hash values, so there's not going to be as many collisions, but let's say for some chance you get a collision. What happens is you get different clients in the same group, but they can't interoperate because the new clients can't encrypt the old clients' data set because they don't actually have the key. So when they get that encrypted block for whatever messages, they're going to fail in encryption. They're going to throw exceptions. So being in the same group gets you nothing for key collisions because it gets you put in a map within the message router, but you can't do anything, and you don't even know you're in the same group. If anything, it prevents you from doing anything on the inside. So by trying to force key collision, you're really rendering your ability to participate in the network kind of useless. That might be something eventually I'll look into to kind of rule that out. I think that's a potential for an attack vector. I really haven't spent a lot of time looking into it. If you've got ideas, I'm open to ideas and suggestions, but I see that as a potential for making better. Finally, there's a tunnel message, and what that does is clients will open a socket to the router, message router, so that you can get really quick real-time callbacks. So when I did that search for AC/DC, the router called back right away. What was really going on was I was sending the router a message saying, I got a search, but I'm not going to tell you what it is. It's this encrypted block. So forward it to the group members. They forwarded it to the group members. One of the group members decrypted it and said, oh yeah, I got highway to hell. I'll forward that back to you. But I'm going to encrypt it in the block first, send it back to the router. The router gets that, and it's like, okay, I know this is a search response, but I don't know what's in it. So I'm just going to forward it back to the guy who originally wanted it through this out of bounds and sync the socket channel. And when I get the request back, I then decrypt it and I put it on the screen. So there's really three different socket interactions going on in that simple search. So you might be thinking, okay, from a network scalability perspective, that's very limiting, and you would be absolutely correct because I only have 2 to the 16 sockets available to me. Now, Raven pointed out that that's not necessarily true anymore, that different operating systems abstract that and stuff. I'm not as up to date on operating system socket limitation abstractions, but even if that's not the case, even if that's a hard limit for most operating systems, in 2.0 I'm going to solve that because message routers will be able to trust one another. So you can very well have an aggregate group span multiple groups across message routers. So if all of us in this room choose the same key image and derive the same key, but all of us connect to 10 different routers, right now we would be in 10 different groups, even though we have the same image. In 2.0, if those routers know about each other through an opt-in trust, we will appear as one group. And so the limitation of an upper bound on 2 to the 16 ports for a socket is no longer a consideration. And let's be honest, that if you had over 65,000 clients trying to connect your little Raspberry Pi at home, you'd probably encounter hardware limits sooner than you'd run out of maximum number of ports, right? So those architectural concerns I'm fixing in 2.0 with the idea of trust. And finally, you have a quit message. Why do you want to quit? Because you want the router to clean up its memory and remove the key from the group and stuff like that. Advanced messages are things like search, group, browse, initiating a transfer request, downloading and uploading packets, pinging and requesting the info. You can ask the router how many sessions it has or how many clients it has. That comes automatically. I don't know if you noticed that when I have a client up, there's some values of, hey, there's 2 groups in this router and there's 2 clients. So the router will give you some very limiting information. If you don't want to send that back, you can uncheck that. For example, if you don't want the clients to know how many clients have joined or how many groups, you simply uncheck the info and it goes away. And then finally, chat in 2.0. So this is the DemonSaw network. This is one permutation of the network. This is not the end all. This just happened to be the one that I thought was cool when I was drinking way too much coffee at 3 a.m. one morning. What do we have here? Well, what you're seeing here is a session propagation. We're assuming this is a 2.0 feature. Everything else here is available now. You get 2 groups here. You have the Electronic Frontier Foundation group. Yay, I saw a hat or a shirt with EFF on it somewhere here. And then you have the OFF, which I guess is the antithesis of the EFF in my work. So these are 2 different groups. Basically, it means that there's 2 different images that these clients are using. So C0 and C1 are connected to message router 0. C2, 3, 4, and 5 are connected to message router 1. In 2.0, these 6 clients appear in the same group, the EFF group. Well, C6 and 7 are in 0FF, and they're connected to router 1. So this is a great example of how a message router can service many groups or one group. And all the other routers on the extremity, router 2, 3, 4, 5, and all the way up through 9, are simply acting as data routers in this capacity. Now, a router can be a message router or a data router, or both. In this capacity, let's assume that 0 and 1 are just message routers and the others are just data routers. So what we've shown by this is we have 8 clients all downloading and uploading data, but the actual file transfer is being routed through 8 different data routers. So if you really think about it, this setup costs about $30 a month to host right now. So for $30 a month, each client has its own dedicated shared environment for funneling ones and zeros for all its transfer requests. You can see how this model can very, very easily scale up. You add more clients, you add more data routers, and at $3 or $4 a pop, it's very, very easy to scale. An interesting use case would be a university. I would love to get access to a college or a university where they have hundreds of students or sorority members or fraternity members where they want to experiment with this and find out where the performance bottlenecks are in terms of data routers to message routers to clients. I haven't done any really stress testing yet on this, but it is interesting to me. So then if you have contacts or want to do something and stress test, or even want to pen test DemonSaw in general, please send me an email, send me a tweet, etc. Because I'd love to partner with you. Because I haven't had a lot of time to pen test and I haven't had a lot of time to stress test. But this is how the DemonSaw model could be set up. And once again, you compromise R2, compromise R6, you don't know who's doing what. You compromise all the routers, and you still know nothing because you don't have the images. You compromise C7 and C5 and all the routers. You know, basically at this point, if you compromise them, you would know the image, you would know the drive key, but you would have no clue what the other people were doing. So unless you happen to sniff all the traffic on all the network and got all of the Diffie-Hellman session keys in route and decrypted all those messages individually because they all have their own session key, and then decrypted the group data on top of that in order to know what they were doing. So in order to compromise any client, you have to compromise his image and you have to compromise his Diffie-Hellman handshake at the same time. You couldn't simply compromise his colleague and be able to know his traffic by sniffing. Now once again, if somebody's able to compromise the whole network like that, they're probably going to get access to other more important information like financial information. But maybe they just don't want you to share files. I don't know. Let's talk about security and good. Talking about security. Right now, in 1.5, DemonSaw uses the following cryptographic algorithms. I use AES, Diffie-Hellman, SHA-384, and I'll show you an example of that. I was using SHA-128. One of my followers said he wanted to use it for, I think it was a college campus, or no, it was an observatory. Yeah, some administrator at some sort of NASA observatory or university observatory wanted to use it. I wasn't really sure what for, but I was cool with it either way. So he had suggested SHA-384, so I went ahead and converted it to SHA-384. For 2.0, you'll be able to choose not only your hash algorithm and the cryptographic strength of that hash, but you'll be able to choose whether you want to use hashes or HMAPs, which you can then use as salt value. Why is that important? Because let's say you want to prevent rainbow attacks from the hashes on your file data or file names. Now you can simply choose, I want an HMAP for a SHA-256 or a SHA-512, and I'm going to choose the salt, and nobody's going to be able to rainbow attack. That's totally possible in 2.0. So once again, I'm adding more security. I say we, but it's for royal we. It's just me and DemonSaw. So you'll be able to add as much security as you want to level up to, or you can decrease it. It really depends on your usage patterns. There's multiple layers of encryption. You've got the session key, the group key. Transfer key we've kind of talked about already. What the transfer key is just a different session key. When a client connects to a message router and does a handshake, that generates a session key. Well, when I as a client get rerouted to a data router, there's the same handshake that goes on, which establishes another session key only for that transfer, and then that key goes away. So that's what I call a transfer key. a new session key for interaction between a client and a message, data router is all it is. There's also a passphrase key that routers can use. Let's say you want to host your message router or your data router, and what you don't want to do is you only want your cool friends to join, but you don't want your uncool friends to join. All right? What you do is you put a passphrase on it. You simply choose a string passphrase that I then just use a password-based key derivation function, or PBKDF, I think it's 2 right now, and you derive from that key that you then use to AES encrypt the very, very first handshake. So if nobody knows that password, they basically can't handshake with the router. So that's an additional thing you can do. I've had people request that they want to host a message router, but they don't want anyone to join. So yet again, another layer of encryption on top of it. It gets crazy with 2.0 beyond any of this. Like, it's insane the amount of complexity that I've worked really, really hard to put into this app to support any permutation or any number of configurations. And this is just the beginning. And I say that, I tweet that, and I can't say that enough. This really is just the beginning of DemonSaw. And I think with 2.0, we're going to see additional use and additional excitement with this, especially when we get on OS X and we get the client on Linux and Raspberry Pi and Android, and you can secure chat with your friends without worry, and it's free. I think we're going to see a lot more people excited about DemonSaw. Yes?
Couple questions.
Sure.
So, does all the messages and data actually go through route?
Not through this. No, not at all. No, and I'll show you why. Once again, it goes back to how you configure your router. If you have one router that does data and message, then yes. But if you break it up like I do, your data will never go. Even crazier in 2.0. I think I kind of alluded to this. I'm throwing so much information at you that I'm surprised no heads have exploded yet. So that's a good sign. But
You're trying.
good.
Trying.
Please
Keep
no
trying.
explosions, at least during my talk. Afterwards, it'll explode. But with 2.0, you'll be able to have multiple data routers service one transfer request. So you go download a file, and instead of having the whole file be sent through one data router, you'll break it out into how many data routers that message router has available. So that message router has 20 different data routers available. Your file will be split across 20 different places. So if one of those is compromised, the other 19 out of 20, or 95% of that data won't. And each one of those data routers will have a separate session key for that interaction, specific lifetime. And once that transfer is done, session key is destroyed, and any other transfer will have new keys generated. We can introduce randomization to that. We can introduce offset chunking, so maybe it's not a contiguous chunk. Maybe there's a lot of different mutations I can do on that. We can XOR stuff. I mean, it can get crazy. It can do like a cipher blockchain technique. We can make it so even if somebody compromises it, they have no idea what they're looking at. And you throw HTTPS on top of that and remove the DPI element, and you've got a solution that's probably more secure than a lot of military-strength crypto routines, or at least the implementations of those routines. So social encryption. I've alluded to this already. Social encryption is the term that I'm giving to the ability to derive symmetric keys through contextual awareness or shared knowledge. With 1.5, it's knowing about the same group image. With 2.0, I'm actually branding it as social encryption. Because what it is, it's the ability to hide your secrets within the fabric of social interaction. Because we share some knowledge about university.gov and about a birthday, we're able to use that as entropy. So social awareness and social context derive an immense source of entropy from which we can generate strong cryptographic signatures. And I proposed 2 talks for DEF CON 23 this year. One of them is about crypto for hackers, which is kind of cool, teach you all these algorithms, maybe even a hands-on workshop for 4 hours. And the other one is about social encryption. Okay, so passphrase, that's a good question. So passphrase key.
What was the question?
How does social encryption differ from passphrase key, like password-based key derivation stuff on crypt text? So let's say hello world, and I use PBKDF2 to derive some sort of cryptographic derived key, and then use that in output. The difference between that is they're similar. One is clear text that I then use a password-based key derivation function to derive from. The other one is I have a URI. I have some sort of socially available or locally available reference that can be anything, including a string. So the passphrase element right now is really a subset of the full social encryption element, just like group encryption or group image encryption is a subset. So as I was making this, as I did the password stuff, and as I did the group image, finally a light went on. It only took a year and a half to spark, and that's good. And I realized, you know what? This is a small part of a much bigger solution to modern day security, especially file sharing security. Now, this security model doesn't work for everyone, and I want to be very, very clear about that. This security model is not going to replace private and public asymmetric encryption for banks and certs and all that stuff. But what it does is it provides a model for us to be set free in terms of secure messaging data exchange from a peer-to-peer perspective. So it removes the dangers of the client-server model, it removes the dangers of the peer-to-peer model, and it really allows us to be set free. I have a feeling I'm on some sort of list right now by very mean and angry people, and as are probably many of us in this room. But the important thing is allowing us to share freely and securely without fear, and that's what this does. So back to this gentleman's question. How do you secure the messages? Well, this is a really great high-level example. In the green square, what you've got here, oh, and by the way, this is available at DemonSaw.com. I may mention this already. If you go to DemonSaw.com and you go to the talks menu, HackMiami 3, and you click on that, you can get access to the PDF. So feel free to download that. It's available. You're more than welcome to take pictures of the screen too. That's cool. It makes me feel important, so that's awesome. But the green square here is basically just the HTTP post. So every DemonSaw message just is a simple post with a slash. There's no resources. You just get the slash. You don't have any header parameters that are necessary, like very few, like the host. You have to send the host because web servers complain if you don't. DemonSaw doesn't complain, but if we're hosting a data router at a web host, like a .NET web container, it will complain if you don't provide the host. So we provide the host, which is the IP that we're going to, or the URL that we're going to. That's really it. Everything else is encrypted beyond that. So the orange box there is basically everything that's encrypted by the session key. So when a client handshakes with the router, either a message router or a data router, and generates this session key through Diffie-Hellman, the orange box is encrypted with that key. So any client B wouldn't be able to do a man-in-the-middle attack for client A and be able to use his key to decrypt his buddy's message packet. That's not possible because the keys are different. So inside of that orange box, you'll notice that orange there and brown there. You'll notice that there's very, very little information. The only information that I put in here is stuff that the routers need to route. So all you have is you basically have the header, the message, and the data. The header is stuff like the version. Why do I version it? Because as I release new 2.0 and 2.5, I want to be somewhat backwards compatible with at least all the minor versions, if not the major versions. So if you're using the older client and you have maybe version 3 and the router's using version 4, it will know to maybe parse it with a version 3 parser. So that's why the version's there. I'm not using the notch yet. I meant to, I ran out of time. It's just to prevent replay attacks, was the idea. I haven't got around to doing it. Maybe I'll do it in 2.0. It's a good thing to do, right? Prevent replay attacks, but at the same time, it's like, I don't know, is anyone going to try to replay attack with requesting a download? It doesn't seem like a terrible thing, but eventually I get the nonce in there, and it's not a lot of it. The session, so this is an HTTP message. You'll send your session in the HTTP wrapper, but I also encrypted in the message so you can't try to do some sort of session spoofing or rejection. So I don't think that is in 1.5. That might be 2.0 feature. I can't recall. I may have put it in 1.5. That I think might do just that stir comp is basically what I'm doing, but I don't know. Don't quote me if I'm not doing it. If I'm not doing it, it's on the list for 2 hours. If I'm doing it, then good for me. I'm super smart. Finally, in the JSON message, you have stuff like the ID. Sometimes the unique ID is needed for like transfer requests. As you're routing through a data router, it needs to know what transfer you're uploading or downloading to. So information that's specific to really the session state of that router at that time. The type, so things like, is this a search? Is this a browse? Is this a handshake? Is this an info or payment quick? And the delay. Sometimes the router will want you to wait. I initiate a file request and I try to download, and nobody's uploaded any chunks yet. The router may say, you know what, why don't you wait 3 seconds because you're super fast and the uploaders haven't gotten to you yet. So that's used as a throttle, and that's configurable in the UI. It's used as a throttle to kind of maybe not kill the router, is what it's used for. And then finally the data, which is the red encrypted block. So as you see, the message layer is where the routers live, and they don't have any access to the real exciting stuff that the clients need. Stuff like the red stuff's encrypted with the group key. Stuff like the objects and the raw ones and zeros, and what's your search keyword, and what's your filter? Do you only want MP3s, or do you only want movie files, or do you only want documents, etc. And then other stuff like the chunk ID, which is the offset in the file that you want to start from, because you can restart at certain offsets if you decide to pause or stop a transfer. In 2.0, hopefully, you'll be able to shut down, and when you restart the app, it will restart the transfers wherever they were off. I never got around to putting that in. It seems like such an important feature. You would have to save out the state of the transfers, and I was a little concerned about that because I didn't know if I wanted to make disk resident like what you're trying to download. So I never put it in for that reason. But most of the time when I use DemonSaw, I finish the transfers before I shut it down. So that might be something I add in 2.0. It may wait. If you guys want it sooner, let me know. If I'm a fool for not having put it in, please let me know, and I'll hold it up if I do. And that's really it. So you see the levels of separation, you see the different encryption. If you use a passphrase key, the very first handshake, that will encrypt the order stuff because there's no session key yet. So that's kind of the precursor to the session key. Did this answer your question, sir?
So the client's got the data, right? And this is the message.
How about this? So once again, I promised my HackMiami friends that I'm going to give you a level of detail that I've never revealed before. Ultimately, I'm going to publish the protocol. I'm making it open source, this whole thing. I have no idea. And that's the honest truth. Literally every waking spare moment of my life as a single guy is dedicated to writing code right now. So there's a reason why I continue to be single, and it might have something to do with DemonSaw. But nonetheless, I write the code. In this example, this is just a real-world search example. And if you hooked up Wireshark and to a network where DemonSaw was running, and the group image was chosen, the gray stuff and the red stuff would be encrypted. So you would just see a huge base 64 blob there that would be all encrypted, gray and the red, in the session key or the passphrase key. The red is doubly encrypted, once with the group key, and then again at the router level with the session key. So you wouldn't see this in the message. Now, if you choose not to use a group image in the client, what you're doing is you're saying you don't want to extra encrypt client to client. So you can opt out of the image, and what happens then is the gray and the red are only encrypted with the session key. So that's a performance tweak. That's also something that can be done for networks that don't need that extra overhead. There is overhead, computational overhead with more encryption. So I encourage everybody to use group keys or images just because there's so much security. If you don't do it, you're basically no longer super secure. But if you're just sharing photos with your family, maybe you don't need an extra decryption segment. So that is a possibility. The search response would be something like this. This message format, by the way, was 1.0, and I maintained backwards compatibility. But through the evolution of this, I realized some mistakes I made with my JSON format. And anyone does a lot of JSON here, and you're looking at this, and you're like, dear God, he's insane. Does anybody? Please, It's okay to judge me on my JSON. It's okay if you want to. Well, there's a couple of mistakes I made here in JSON. Number one is I kind of embedded JSON within JSON, which creates this weird extra markup, which I found to be problematic with parsing later. It was an error in my ways. I'm going to correct it for 2.0. But also some of the tag names don't need to be this long. I mean, I don't need to say files or size or, I can say something shorter like F or S. I mean, maybe it's better to put files or stuff. I don't know, but I don't need to have these lengthy descriptive names in JSON. Another thing is I don't compress any of this beforehand, so that might be a performance optimization. But this is an example of the real results. All of that is base 64 when it gets to the client. Decode it, decrypt it, or it's decoded and decrypted, and then you parse the data. So eventually I'll publish the whole spec, maybe after 2.0. I don't know. I'd like to sleep more than 5.5 hours a night someday. So that includes this conference too. Now, that's 1.5. That's the security of DemonSaw. That's what I've done the last year and a half of my life to develop a file sharing app that allows us to secure freely without consequences. I promised you before that technology will set us free, and technology will continue to be the deciding factor between extinction and survival. And with DemonSaw 2.0, there are some amazing things that I'm working on. And I've had some goals with 2.0. At the start, right after DEF CON last year, when I got back, after all the interviews and after all the articles were written and after all of the questions were asked and all that hype kind of faded away, I said, you know what, I need a goal. I need bullet points that I need to focus on. And I came up with 4 of them. 2.0 needs to be, I need really to make it everywhere. I promised that DemonSaw is secure, anonymous, free, and everywhere. Spelled safe. It's not really everywhere when it only is on Windows, right? Okay, so that's visionary thinking on my part. One of my goals is to make it on Linux, Pi, OS X, and hopefully Android if I get to. 1.5 is halfway.
Beagleboat?
I'm sorry?
Beagleboat?
Is Seth here? Seth, who spoke about the fun of implanting chips in his hand, is going to try to run the Raspberry Pi build on Beaglebone Black because it's a Debian build as well. So it might also work on Beagleboard. We'll find out. I don't know. I don't have Beagleboard. It sounds cool. If somebody wants it, I made it run on Pi because one of my friends asked for it. So why not Beagleboard, right? Make it everywhere. Number 2, simplify the interface. The older interface was a bit complex. It was a programmer interface written for programmers. And one of the things I realized, I suck at UI. I didn't just realize that. I've known that for many years. I suck at UI. And I am a C++ programmer who likes to dabble in hacking. That's what I do. I work with APIs. I like to write code. I like to do asynchronous, multi-threaded crypto stuff. UI is not second nature, and I struggle with it. And so I worked really, really hard on 1.5 to kind of think about the interface from a non-programmer perspective. And I think I achieved success with the ability to kind of cater the interface and give a modern feel and allow for the CSS modifications. I'm open to suggestions from you, but I think it's a world of improvement. But I'm still not a UI expert. And one day when I have funding for DemonSaw, I will hire a very, very smart and intelligent UI programmer that I will just give full control of the UI to and never worry about it again. Number 3 is heightened security. There were some gaps in security with DemonSaw 1.0. Mainly, you couldn't install, you couldn't use HMAPs, you couldn't salt, you couldn't increase the key size, you couldn't change your algorithms. There are a lot of things I wanted to do better and more secure. And I focused on that. DemonSaw 2.0 is about 20 times as secure as 1.5. It allows you to do 20 times more. Now, once again, there's a price for stronger crypto and paying performance. But for some people, that's acceptable. DemonSaw will never be as fast as a direct peer-to-peer connection. Because the fastest way between 2 points is what?
Straight line.
A straight line. DemonSaw has slightly straight line. It goes straight and then it goes straight again. So DemonSaw will never be able to be faster than a direct connection. However, with 2.0 and with the ability to divide up chunks of your file across n number of data routers, it will be not only as fast, but it will be faster. And how does that work? It's a feature that I call instantaneous download. And that's number 4, more features. DemonSaw 2.0 has to have more and do it better. It just, as I say, I swear, shut up. I'm not being recorded. Okay. Well,
It is.
okay, all right, well, it just needs to work. That's kind of what I say. You just turn it on, it just needs to work. When I released DemonSaw 1.0, it had some bugs, some pretty bad bugs. I rushed development. DEFCON 22 was a lot of stress. It was my first time speaking there, and I just didn't have time to test. I've since fixed a lot of those bugs. It's much more stable now. 1.12, it's really stable. I even had a follower who was running DemonSaw on a CenturyLink wireless connection, and I didn't even know that existed anymore. But he was running it on that, and super nice guy, very helpful, helped me troubleshoot and test. And DemonSaw wasn't stable. It kept erroring out because a wireless ADSL connection apparently is unstable, and you can't rely on it.
Apparently.
So I worked with him to ensure that the connectivity issue we retry at all possible times. And so he finally told me, you know what, it's working great now. I was able to transfer like 4 gig file without problems over my ADSL wireless connection. I'm like, great, that's made my day. So it needs to be better, it needs to just work. An instantaneous download is the idea that with 2.0. Imagine getting an 500 meg file in less than a fourth of the time it would take for you to get a direct connect to that file. With the ability, with ISPs and fast internet like Google Fiber and some of the 105, 150 megabit per second offerings, we are not fully utilizing our download speeds right now. We're not fully utilizing them for a variety of reasons, because of NIC restrictions, because of single-threaded application restrictions, there's a lot of reasons. But with DemonSaw 2.0, you'll be able to multi-thread, and you'll be able to better use your network bandwidth to get lots of chunks at the same time. So if you have the gigabit fiber, and you have multiple data routers all serving chunks at the same time, you should theoretically be able to download a file in a tenth of the time, if not less. Now, this is fully untested, this is all theoretical, but it's based on logic, and it's based on sound reasoning. So everywhere, faster. C++ is a lot faster. The C++ versions of the routers is about twice as fast as the C# version. I tested it out. Anywhere from 50 to 100% faster. I've rewritten all the code. I mean, I spent 3 to 5 months just rewriting the code last fall. Things like compression, I might add. We talked about new crypto algorithms, use of defined salts, choice of algorithms and key sizes, streaming. Who would love to stream? Like, wouldn't it be cool to sit on your couch, bring up DemonSaw on your phone, join your group of 1 million friends, close friends,
Yeah.
say, oh, I want to stream that movie on my Chromecast now, and just have it work. All right? So don't go through Popcorn, don't go through Torrent, you don't go through any of this. It's just stream now and shoot it off to my Chromecast, or stream now on my phone. All that is well within the realm of possibility. You can stream now by simply starting the file and opening it up, as long as the file supports that without being fully MKV files and stuff like that, MP3s. But having actual streaming where you don't have to download the whole file in the background is something I'm going to hopefully get done. Session propagation we talked about. Auto-sync files and folders replacing Dropbox. No more cloud, no more Dropbox. That's tough for Dropbox, everyone say. Sorry, Dropbox. But instantaneous downloads, chat, secure chat is something that we're bringing back to file sharing. I'm excited about secure chat because it's such an easy feature to implement. It's so much easier to transfer 100 bytes than it is a billion bytes. It's so easy. Chat, it's instantaneous and it's easy and it's secure. So chat is something that's really an interface question. What's the right interface? To chat with an individual, to chat with a group? What's the best interface? Programmatically, it's done. Just simplifying everything. DemonSaw shouldn't be complex. And once again, social encryption. Social encryption is, I think, the key to the future of DemonSaw and the future of this type of security model in using as entropy our social awareness of one another. So in summary, I believe in the right to share, and that's what motivated me to make DemonSaw and to continue to work hard on DemonSaw and to continue to release new versions, better versions. A lot of that comes from your support and dedication and your willingness to follow me and your willingness to give me great ideas and tell me that there are bugs in the software and help me fix them and test them. But I believe we have the right to share. And if you look at the back of the t-shirts that some of you won, and you look at that quote that I said at the very beginning, the solution to file sharing isn't to stop doing it, but to stop governments and corporations from knowing that we're doing it. Do you believe in the right to share? Digital self-expression is achieved when we are able to exercise our right to share. When we digitally express ourselves as individuals and as group members, we exercise that right to share. It's a fundamental right, just like the right to free speech. And it's something that we haven't embraced and that we've started losing over the last few years. I believe it's time to reclaim it. I believe it's time to start using DemonSaw, spread the word, get more people sharing freely, without fear and without consequence. So the next steps. This is kind of my plea to you to help me. This is the big slide, as I call it. The best is yet to come. 3 months from now, 2.0 is going to come out. And I need your continued support. You can follow me on Twitter. The link will be on the next page. You can email me. It's just Eijah, E-I-J-A-H, at demonsaw.com. That's also on the next page. I'm available the rest of the conference. The rest of the night, we'll do the workshop after this. And the next day, tomorrow, I'm available to chat. You want to have a beer, you want to have a meal, you want to talk about stuff, you want me to bring a notepad and a paper and write down all your great ideas, we can do all that. I'm fully open to that. But your suggestions, your bug fixes, your data testing really tremendously make a difference. Like, I can't state that enough. My friend in Portugal, he was the only one that suggested Pi. And if you're loving the fact that this is running on Pi right now, it's because one man made one tweet in one evening from halfway around the world suggesting this idea. One instance in time created DemonSaw on Pi. So not only does one person can make a difference, but one person absolutely does make a difference. So that idea that's in your mind right now, where to take this to the next level, you might very well be the only person that has that on the face of the earth, and if you don't voice it to me, it will not be heard, it will not be heard. So I need to hear that from you. If you're the only one who has it, even if you're not, I need to hear it. Email, Twitter, DemonSaw 2.0 is at DEF CON 23. Assuming they accept my speech, I'll be unveiling it on one of the 2 talks that I give. Otherwise, I'll still be launching it there. I'm there whether I talk or not. There's tons of parties. I've never been there for mostly parties, but I will be releasing 2.0 there. So, as I mentioned before, best is yet to come. Believe in the right to share. My name is Eijah,